This lesson is 2.6, which is solving absolute value, which you should remember from chapter 1, and inequalities that we've been doing this whole chapter. So this is really a combination of chapters 1 and 2, and it is also the last lesson in our chapter 2. So if we look over this problem right here, this was one of our problems back from chapter 1. And many of you were really good and you were able to guess that the first answer was x is 1. You knew that one, but some of you struggled a little bit to do this other answer. And so we showed you a little trick by what you do is you drop the absolute value and you make the right side negative, and then you simply solve the equation, and now you have both solutions. So today's lesson is going to take this problem, only it's going to switch it to an inequality. So do you notice how these two are very similar? So our answers are going to involve these numbers, but it's going to look a little different, okay? So let's go ahead and do the same thing. We're going to go x plus 2 is less than or equal to 3. And then just like normal, we would solve it. And so we have one answer. And now on the other side, we're going to do x plus 2. But what happens with inequalities when you make something negative? Yeah, you got to switch your sign like that. So we're still going to subtract 2. So notice how the 5, do you see the numbers, the negative 5 and the 1? But do you see how the symbol had to change? Now, as you can tell here, this is a compound. But the problem is, which compound is it? Is it the and or the or? So let's go ahead and graph this. Now be careful, 1 is bigger than 5. So let's, negative 5. So let's make sure we graph that correctly. So negative 5. Okay, so there's my two numbers. So I have x is less than or equal to 1. So I'm going to go dark circle, and it's going this way. And then x is greater than or equal, so filled in, greater than this way. Look at this drawing. What happens when they're overlapping in the middle? Is this the and or the or? Hopefully you're answering the and. So when we have an and compound inequality, we need to rewrite this. We don't just squeeze the word and in. So if you look at your graph, it's a little bit easier from the graph. You do the low, you put your variable, you put your high. And if you always keep it this way, point your symbols to the left. So put your symbols to the left. Now I know that looks backwards. Now this one matches. Look at this one. But notice how it's pointing towards the negative 5. It's pointing towards the negative 5. And then the only thing we have to do is just make sure we put the bars underneath. And now we have the correct solution. Okay? So sometimes the graph is really helpful. So let's practice another one or two and see if we can answer this question down below here that's kind of in bold. Is there an easier way to tell? So let's just go through a couple more to see. All right, we're going to drop our absolute value and not change a thing. We're going to subtract the 2. We get 6. And we're going to drop the absolute value. And when we make the 8 negative, we just have to reverse our sign. And then we're going to subtract the 2. And we've got our two numbers. Now again, notice how they're reversed. So negative 10. So it takes up almost the whole number line. So I have y is less than 6. And y is greater than 10, negative 10. So do you see how they're pointing the same direction? That means it's going to go over top of each other like that. So that's the and again. So let's go our low, our variable, our high, and then we point our symbols to the left. And in this case, it does not have the bars underneath, so we just leave it alone. Okay? Let's try one more and see if we can come up with another little kind of shortcut. So we're going to drop the absolute value. We're going to times both sides by 3. Now, because I'm multiplying by a positive, I do not have to reverse my sign. Now, on the other side, On the other side, when I reverse that sign, when I make that 2 negative, I have to flip my sign like that. Now notice I'm still multiplying by a positive number. So because I'm multiplying by a positive, I do not change my symbol again, even though my answer comes out negative. It's only because what you're multiplying by. So my symbol's fine. So I have -6, positive. I've got greater than 6, and I have less than -6. Well, look at that. Do you see how there's a big gap? That's the or. Now, hopefully you're noticing that the graph really helped me know what I should use, whether it was the and or it was the gap for the or. But there is another short way to tell. So if you look back up at the original, you see these symbols? If you have the less than, it's the and. If you have the great or, it's the or. So let's write that down. Let's write down right here. We'll say less than is the and compound. The greater is the or. So let me just look at this. I can tell you right here, even when I move this 4 over, do you see how when I move the 4, it's not going to change the symbol? This is the less than. It's going to be the and. Now this one you have to be careful because when you move numbers to the other side, you just got to make sure it's not going to flip your symbol. So let's go to number 3. Oh, sorry. I apologize, you couldn't see that. Let's go to number 3, and when you move things to the other side, you'll be able to tell better. So I apologize, you couldn't see. So let's move the 4 over. Right there. This is really where you want to be. You want your absolute value to be isolated, and now you can look at this symbol and you can say, well, that's the less than symbol. I know it's going to be an and. So I really don't even have to graph this. I can already write my answer when I get done. So let's go ahead and solve. So I'm going to subtract 3 is 1. And then over here, remember, when you make this side negative, you're going to have to reverse it. So we're going to reverse our symbol. And then we're going to subtract 3. And notice, this is going to be the and solution. But if you're not sure, you can graph it. I can do the the -7 and the 1, just rough sketch here. And I can show you. So it's going to be less than, and then this one is greater than. So do you see how just by a rough sketch, I could tell you which one it's going to be? So you're going to put your low, your variable, your high, point your symbols to the left, and then these ones don't have the bars underneath, so then you're just done. So really, the graph is more to help you try to decide if it's an and or. So if you want, we could just take the graph off if you think you could do without it. We just put it on there if it was needed. So if we take a look at number 4, right now I'm thinking this is going to be the or, but I just want to move everything to the other side to make sure that it doesn't change this symbol. So the first thing I'm going to do is move the 7. Then I'm going to divide off the 3. Now I can tell you that this is the great or. So I can already tell you right now that this would be the or compound. But let's just go ahead and solve it. Dropping the absolute value and not changing anything. And then I'm going to drop the absolute value and change my symbol. And now I'm going to subtract 1. If you want to rough sketch it again, you could. -3, 1. Notice it's greater than or equal to, so it's going out. And then this one is less than or equal to, so notice the gap. If there's a gap like that, all you got to do is put the word or in between, and kind of circle. You don't really have to rewrite the ors. It's the ands that you have to rewrite. You can't just squeeze the word and in between, okay? So that is really the entire lesson. And then if you notice on the back, some of them just get a little bit more complicated. There is definitely a few on here I think you should watch out for. So I would go through this with me if possible. A second. So on the back side here, I definitely would say make sure you go through these with me because there are some that they have a little kind of twists and turns to them. So let's just make sure we kind of go through them. But at any time you can always pause, you can try them, and then watch the video to kind of see, to make sure you know how you're doing them if there isn't any tricks. Now again, if this is a little difficult to see on the projection, please feel free to open up the original document so you can tell that this is like a plus 10 and things like that, okay? Now, before we can actually determine what type of compound inequality this is, we need to get this part alone. So we need to really isolate this absolute value before we can really tell if this is an and or an or. So let's go ahead and start by moving that 10 over. So I just subtracted the 10. I'm still going to move off this 3. And from this stage right here, I can look at this symbol and tell you that this is the less than. And because this is the less than, I know it's going to be the and inequality. But I cannot make that determination until I isolate this piece. So now that I have it isolated, I'm going to go ahead and do my split. I'm going to drop my absolute value. And I'm just going to solve it as if it's any regular inequality. And so I'm going to divide off the 2. And so there's one of my solutions. And now I'm going to do the other side. But remember, I do have to reverse this symbol because I made this a negative. And now I'm going to go ahead and solve it. Now remember, I'm dividing by a positive. Even though my answer is coming out negative, I am dividing by a positive, okay? Now this is an and, so I'm going to have to rewrite this. And notice this is my high and this is my low. So I need to switch the order. I need to put my low on the left, my variable in the middle, and my high on the right. And then I'm going to make my symbols point to the left. But notice they both have a bar underneath, so I am going to put the bar underneath. Also, if you notice, we do not have any graphs on this side. If you're still confused on whether it's an and or an or, you could take a separate sheet of paper and you could just do yourself a rough sketch. I've got 2, I've got -7. Notice it says less than or equal to 2, so it's going this way. And then it's greater than or equal to 7, so it's filled in, and it's going this way. Do you see how it's overlapped? Then I know that this is an and solution. So even though there's no graph provided here, if you need one, go ahead and sketch one out, and it'll help you determine. Now, having said that, number 6 has a trick. Take a look at number 6. Notice the absolute value is isolated. Notice this is the great or, so this is telling me it's an or, but what do you notice right here? Can absolute value be greater than a -4? Should be saying yes. Absolute value will always be greater than a negative, always. So this is all real numbers. This, you can pick any number you want for f. You can pick 100, you can pick -3. You can pick any number you want for f, and this will work. So it's all real numbers. Now, the reason why we don't say infinitely many is because infinitely many says there's a lot of answers, but not everything. In this case, we want to say everything. So we use the all real number symbol. So let's go to number 7. If you take a look at number 7, notice the absolute value is isolated. Notice this is the less than, so you might be thinking and. But again, we have a negative. So creatures of habit, we want to jump back to this solution. We want to say to ourselves, okay, this must be all real numbers, but be careful. This is the less than. Can absolute value be less than a negative number? Can it be smaller? So can this value come out to be -3, -5, -10? And the answer is no, because absolute value will come out positive. How can a positive number be smaller than a negative? Okay, so this one is no solution. So the key here really is the symbol with a negative. So if you have the greater than with a negative, it's all real numbers. If you have the less than with a negative, it's no solution. Now, I don't want to tell you necessarily to memorize that, just to memorize it, because over the years we get too many things that we have to try to memorize. And so I want you to be able to logically think through absolute value, okay? Now, when you go to number 8, they're trying to trick you here because I see this negative and you're like, oh, she just told us if it's the greater than symbol, it must be this one. But you have to get this absolute isolated. So we need to move this to the other side. So if we move it to the other side, we get 9. Now you decide, can I solve it? Sure, 9's positive. I can solve this. And notice this is the greater, so this is going to be the or. You cannot make a decision until your absolute value is isolated. So please, please make sure the absolute value is isolated first. So in number 8 now, what I would do is I would just go ahead and split it. So I would drop my absolute value and I would move my 7. I divide off the 4. There's 1. Now, because this is an or, I can just go ahead and write the word or, because I'm not going to have to rewrite it. I can just slip that word in there. Now I'm going to drop the absolute value, but I do have to switch the sign because I'm changing it to a negative. I'm going to move the 7. I'm going to divide off the 4. Now remember, I'm dividing by a positive. And so again, if you're sort of like, I don't know if that's an or, let's just quick sketch it. We have -1/2 and we have a 4. So I'm going to go greater than or equal to 4, so filled in 4. And I'm going to go less than or equal to -1/2. Do you see the gap? So I know that this is an or. Notice my number line isn't perfect, but it got me to the same answer to notice that there was a gap in the middle, okay? So why don't you try it here? Now that we've gone through a few of these, why don't you pause and try numbers 9 and 10 on your own? All right, if you've paused it and tried this, number 9, you should have moved the 6 over first. And we're just trying to isolate that absolute value. And right there, once this is isolated, there's the red flag. Absolute value will always be greater than a negative. Greater. It's always going to be greater. So this is all real numbers. Okay? Let's do the same thing on number 10. Let's get this absolute value alone. So let's divide off that coefficient. But remember, because you divide by a negative, you're going to have to reverse that symbol. Big red flag again. Negative. But notice your symbol. Will absolute value be smaller than a negative? No, it will never be. So this is a no solution. So again, less than, less than. Notice the bar underneath, the or equal to bar, does not affect my general answer here. And so that concludes the last lesson in chapter 2.